Hi, this is Characterization of Granules Physical Properties Experiment, Calculations and Data Analysis part. Our objectives were first to evaluate granules flow properties via calculating 5 different numbers or parameters. These are flow rate, angle of repose, Carr's index, as well as Hausner's ratio, medium particle size, and loss on drying or moisture content. Then, after doing so, we need to evaluate our binders or the binders used in preparation of these granules and determine the best binder based on these 5 different parameters. To do so, we will calculate the flow properties indicators we mentioned. And here we will build up our Excel tables, as you can see. To start with, flow rate was measured via measuring the flow time of 100 grams of granules as well as lactose. First, for each granules and for lactose, calculate the average flow rate of the 3 trials. Use Excel formulas. Please here use maximum 2 decimal places. Flow rate by equation is equal to the mass divided by the time required for this mass to flow through the standardized funnel or assembly we used. Then it is equal to 100 grams divided by the calculated average flow time. As you can see. Angle of repose calculations. First, start with calculating the average height. Once again, the angle of repose was measured in 3 trials as we did with the flow time. Then the average height is the average of the 3 trials. And again, use Excel formula and equations. Now, to measure the radius, we have first to measure the average diameter for each trial. Remember, we measure 2 diameters per each trial. As you can see, summation, then divide by 2. After doing so, we need to calculate the average of these averages for each granules or lactose. Then the average diameter, the overall average diameter, will be equal to the average of the 3 averages from each trial. Again, as you can see. Now, the radius. The radius is 1/2 the diameter. In angle of repose characterization, you can use up to 2 or 3 decimal places. Now, to reach to the angle of repose, we will calculate it via calculating tan, the tan value of the angle. The tan is equal to the opposite divided by the adjacent. Then it's equal to the height divided by the radius. The height is the average height of the three trials, and the radius is calculated from the average of the averages of the diameters. Now, to calculate the angle of repose, I recommend to calculate the angle first in radians, then to calculate it in degrees. This will make it much easier for you. Use the correct function as you can see from the Excel and calculate the value of the angle in radians. Now you can convert it to degrees. Again, use the correct function from Excel, which is degrees, and in degrees you will convert the radians value to the degrees value. This will be much easier for you. Now, to calculate both Carr's index and Hausner's ratio, we have to calculate the bulk and tap density. By definition, density is the mass of unit volume. Bulk density is the mass of unit volume of the bulk volume. Then it will be equal to, as you can remember, we measured these volumes for 50 grams of granules or lactose. Then bulk density will be equal to 50 grams divided by the bulk volume. When calculating the densities, you can use 4 decimal places, but not with other numbers. And tap density will be equal to 50 grams again divided by the tapped volume. Now, Carr's index equation should be applied. As you can see it in your manual, Carr's index or compressibility index is equal to tap density minus bulk density divided by tap density times 100%, as we calculating the index as percent, while Hausner's ratio is equal to tap density divided by bulk density. It is calculated as a ratio. Here are your calculated numbers. Now, to calculate moisture content is equal to water weight divided by sample dry weight. Water weight is equal to wet weight minus dry weight. Then in our equation, moisture content is equal to wet weight minus dry weight divided by dry weight times 100%. While loss on drying is equal to water weight divided by wet weight times 100%. Then here loss on drying is calculated as wet weight minus dry weight divided by wet weight times 100% times 100%. Now, to estimate the median particle size, please use the same method we did in cycle 1 experiment 2 size reduction of powders. And if the curves or the cumulative percentages curve appeared as you can see in this example, you can only use cumulative percent over size to estimate the median particle size, as it will be the same in all cases. Now, build up your portfolio pages as we have learned during previous sessions and experiments. Now, just copy and paste your tables and charts. Always start with results tables, then calculations and data analysis. To make your final conclusion, you need to fill the summary table in your report and determine the overall flow based on the chart in page number 39 in your student manual. This chart correlates cars index and angle of repose. As you can see, how? This is an example. For example, particles with angle of repose 25 degrees and cars index 25%. How to determine the overall flow? First, you have to add a line that is perpendicular to angle of repose starting from angle of repose value 25, and also a line perpendicular to cars index, which is on the y-axis, starting from 25%, which is the value of the calculated cars index in this example. These will have a cross-sectional point, intersection point, in the area of very poor flow, flooding area. Repeat the same for your values. This is how you gonna determine the overall flow from this chart. Then, rank your granules and lactose based on not only the overall flow but other flow indicators, which are flow rate and moisture content. Also, never ignore the median particle size. Based on flow rate, simply particles with a higher flow rate value will have better flow, while moisture content evaluation should be done with respect to moisture content of lactose. Those particles with, or granules in our case, with moisture content the closest value to that of lactose will indicate better flowability. Remember, we assumed that the original moisture content in lactose is the optimum moisture content that will not affect the flow in a negative way. Then these granules will or can be evaluated as better than others. I cannot emphasize enough on the importance of the use of all numbers to evaluate flow properties, since each number or each flow properties indicator is affected by different factors, and these factors are the determinants of the overall flow properties. Again, we cannot evaluate flow properties based on one number solely. Here are some questions for you to answer based on your understanding of the procedures. You will be able definitely to answer these questions. Thank you all.